Motion following project. You can see on the motion sensor that there's a little piece of tape representing where the camera would be pointing. Because we're not going to buy a camera, that's just a bit much. So as Brandon is walking around, you can notice the tape follows where he is, and that's also represented by which LEDs are on, each one representing a different sector. There being 5, there being one here, 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 and over here. And basically, the challenge, some of the as he walks around, the 5 different motion sensors detect where he is, and then they send a signal to the servo underneath to turn the table in which the camera would rest, and it also lights up the LEDs to show which quadrant the person is in, or which section rather than quadrant, so that we can prepare for... Oh wait,
Okay guys, so here we have our design for the motion sensor cameras. Essentially it's built out of black foam board all around, and basically we cut off 5 different sections all around the design of the build, with each sensor being in one different part of the section.
The reason we have 5 different sections is so that if we didn't have these sections, all the sensors would pretty much interfere with each other, and the information would not be read easily. And to make it easier for our sensors to read heat detection, we put these walls around so that we can get a more accurate,
maximized field distance.
yeah.
And also, with that said, we have the camera attached on top with this black foam board on top as well. With the tape here, it detects the tape is towards the front of the camera, so when you walk around, it essentially will move, and the tape is...
the tape represents where the camera would be pointing, because a camera is a bit expensive.
Some obstacles that we ran into that we fixed was cutting the correct lengths and get the right lid for the top of this so that everything can fit together. But eventually we were able to see the problem and cut it to the right lengths.
And one more problem we might have went through is the design, finding or testing the correct shape of it. We weren't sure what shape we should have built this just to get the maximized accuracy for this. So we made sure that every camera had a maximized surface area to detect a lot of
Go.
Hold this here for now. Are you free to
Go.
Just go. Okay, so the electronics portion of this project mostly pertains to each of the different motion sensors sending a signal to the Arduino off of the first few digital pins that are set to input, and then from there the Arduino reads that information, and depending on which input it's receiving, it sends a signal through one of these output pins to 2 places. It sends it to one of these 5 LEDs, or a combination of them depending on how much motion it's picking up, and it also sends it to the servo up top to tell the just to get the servo to rotate to follow that motion. And the reason that we used the reason that the Arduino has 2 different outputs for the signal is so that not only is it easy to tell obviously from where the camera is pointing, but that you can use these LEDs to show which section it's in exactly, so that if you needed to adjust things, either add more sensors or change the position of certain sensors, you could find which one corresponds to which area, and you wouldn't have to track down and reason out where they were realistically based off of the rotation of the servo.
So some of the challenges that we faced in the electrical engineering aspect is the soldering of the motion sensors. As you can see, they're very close together, and there's a lot of wires that we had to find out which one corresponds with which motion sensor and LED.
So how we could have done this better in terms of mechanical build was use plastic instead of foam board, because as you can see, foam board is not very strong. It's very easy to break and to bend. So using plastic would make it stronger and more durable.
And ultimately, another thing to add, plastic just gives a nice touch to the whole entire build. And another thing we could have done, another thing we could have done better is basically to cut the section dividers shorter in length. As you can see here, most of these are really, really long. So if we cut them like half an inch shorter, that not only would just make it look better, it also give the motion sensors a greater depth and range. Because as you can see here, this one has very minimal space just to detect motion. So by cutting these shorter, it will allow greater surface area for each sensor to detect motion.
You may be wondering, what use does this have in the real world? Well, the typical use of this, which is a motion sensing camera that tracks and follows motion, would be, say, for a security camera in a house. We'd put this in the middle of the room, somewhere not easily detectable by a potential intruder, and it would just, if anyone were to break into your home or whenever, you would just set this alarm, or not the alarm, this security system, and it would track the heat signature of whoever would be moving throughout the room of anything that may have transpired during the intrusion, which is very useful.
Yeah, bang bang.
Okay, so some of the things that we could have done to improve the electrical aspect of the project is, as you can see, the wires are in a breadboard. We could have put them into a soldered board. This way, if it should fall or anything, it would stay in place and changes would be easier to make, as you could condense the circuit, making it easier to go about fixing.
And as well, we would like to, if we were to redo this, to either add a little bit of height to the design or a little bit of depth, so that we could fit all of the electronics into the case itself. Just because obviously in this design, anyone who could get their hands on this, whether they be an intruder or the consumer that didn't know what they were making or doing, could potentially mess the circuit up, and the camera and motion tracking system would no longer work.